Hello everyone, I am Gopikannan. Welcome to our maths class. Today the topic is chapter 3 matrices. The miscellaneous problems. Question number 1. Let A equal to 0, 1, 0, 0 for order 2 matrix. Then you have proved that AI plus BA whole power n equal to A power n I plus n A power n minus 1 into BA. This is so that where I denoted as the identity matrix of order 2. Okay. Now let the solution is, we have take A equal to 0, 1, 0, 0. This is given. Okay. Then you have proved the result. You can using mathematical induction, that is principle of mathematical induction, we prove the result. We have take P of n equal to the proof A plus B whole power n and this result we have take. Okay. We have three conditions for principle of mathematical induction. The first case put n equal to 1. Okay. So that is P of 1 such that AI plus BA whole power 1 which is equal to, that is n replaced by 1. So A power 1 into I plus 1 into A power 1 minus 1 into BA. So we know that the result A power 0 equal to 1. Okay. So here left hand side is AI plus BA which is equal to AI plus 1 into 1, 1 into BA. So left hand side equal to right hand side. So for this result is true for n equal to 1. Next case 2. So this is second case. Put n equal to k. We get P of k such that AI plus BA whole power k which is equal to A power k into I plus k into A power k minus 1 into BA. We assume a P of k is true. Assume that P of k is true. This is the condition for mathematical induction and have taken equation 1. Next, third case is put n equal to k plus 1. Then to prove AI plus BA whole power. This is the general case. Okay. P of n. Now we all cases we substitute the value in this given equation. So now we have substitute n equal to k plus 1. AI whole power k plus 1 which is equal to A power k plus 1 into I plus k plus 1 into A power k plus 1 minus 1 into BA. So we prove that the result is A power k plus 1 into I plus k plus 1 into A power k. 1 minus 1 cancel. So into BA. This is we have proved that. Now taking left hand side. So what is the left hand side here? AI plus BA whole power k plus 1. So in this case we rewrite the equation AI plus BA whole power k into AI plus BA whole power 1. The base is same, so you have multiply and the power should be added. This is rewriting that. Because we substitute the value, we have say the given equation 1. The right hand side we have fully substituted for these values. So we get A power k into I plus k into A power k minus 1 into BA. You have put the bracket into AI plus BA by using 1. Okay. Now multiply in each term we get here A power k, here A power 1. So we get A power k plus 1 into I square plus next A power k into I into BA. Then take Ka power k minus 1 into BA. You have multiply here A power k minus 1, here A power 1. So k minus 1 plus 1, 1 cancel. So finally we get k into A power k, b into b, b square sorry, here we first term we multiply by first term, so a power k into b a into I. Okay, now we multiply the second term, we get k a power k minus 1 b into b square, a into a, we get a square. Now we replace the a square value. What is an a square? Here we know that. What is an a value? A equal to 0 1 0 0. So a square means a into a. Okay, so we get 0 1 0, and here again we write 0 1 0. So then multiply the two matrix, we get 0 and here 0 0 0. So a square equal to, we get 0. We replace the values here. Then I square equal to, we know the result, I square equal to I, and I into any matrix we get that the same matrix. Okay, now the all values are replaced here. So we get a power k plus 1, I square value is I, plus a power k into b, I into any matrix we get the same value, plus k into a power k into ba. The whole value you get 0 because a square value is 0, so 0 into anything we get 0, so we don't write this. Okay, finally we get here what is the what we had, a power k plus 1 into I. Okay, here the common value is a power k ba. Have see this. Now take this common out, a power k into ba, so we get 1 plus here k, so we can rewrite a power k plus 1 I plus a power k ba into k plus 1. So here ai plus ba whole power k plus 1. So the by mathematical principle of mathematical induction is true for n equal to k plus 1. Okay, so hence proved. Now continue the second problem. This is the given problem and prove that a power n equal to this matrix. Okay, now we have also using principle of mathematical induction. Okay, so we take p of n is a power n, which is equal to here 3 power n minus 1. So this is p of n. Now the first case is put n equal to 1, p of 1 such that a power 1 which is equal to, we replace it by 1, so 3 power 1 minus 1. We get all powers are 0, so anything power 0 we know that what is the result, 1. Okay, so 1 1 1. So this is then given a, so we have proved for n equal to 1, therefore the p of 1 is true. So the second case, put n equal to k, n equal to k, we get p of k is a power k which is equal to the n replaced by k, so 3 power k minus 1 in all entries. So assume that p of k is true. This this case is always true, we have take. Okay, next the third case, put n equal to k plus 1. Okay, put n equal to k plus 1, so we get p of k plus 1, that is to prove, this is the condition, this is then prove that value. Okay, so p of k plus 1 equal to a power k plus 1 which is equal to 3 power n minus 1, so we replace it by n k plus 1, we get 3 power k. Okay, so 3 power k, 3 power k, here 3 power k, the all entries are 3 power k. So this is, we prove that the result. Okay, now consider the left hand side. What is the left hand side here? A power k plus 1. So a power k plus 1, how can write a power k into a, this is also possible. Okay, so we know that the a power k value is here, we consider this equation 1 by using the condition 1 and we have proved the result. So we have multiplied by this 2 matrix. We have row by column method. So we get 3 power k minus 1 plus 3 power k minus 1. Each row we get 3 power k minus 1 plus 3 power k minus 1 plus 3 power k minus 1. In all rows are there. So all entries are there. We have seen that 3 times. So we can rewrite the matrix 3 into 3 power k minus 1. So the both entries are there. 3 power k minus 1. 3 into 3 power k minus 1. Here 3 into 3 power k minus 1. So here 3 into 3 power k minus 1. 3 into 3 power k minus 1. Here 3 into. So we have complete the matrix. Now multiply the value. What is the value of power? 3 power, that is 1. So we have the base is same. So we multiply, the power should be added. So plus 1 and minus 1 cancel. We finally get 3 power k. Okay. So 3 power k. So the left hand side a power k plus 1 equal to 3 power k. This is then we needed a power k plus 1 equal to 3 power k. So by using mathematical induction, we prove that for n equal to k plus 1 is true. Therefore, p of k plus 1 is true for all cases n belongs to n. Okay. The third sum, a equal to the 2 by 2 matrix, then prove that a power n equal to this matrix where n is any positive integer. This sum also we prove by principle of mathematical induction. So we know that what is the first case? Put n equal to 1. So by the by we have take let p of n is a power n, which is equal to 1 plus 2n minus 4n n and 1 minus 2n. Okay. Now we take p of 1 is a power 1, which is equal to 1 plus 2 into 1 we get 2 minus 4 into 1 minus 4, and here 1, here 1 minus 2. So which is equal to what we get? 3 minus 4 1 minus 1. Here we can see this is then given matrix A. Okay. So the left hand side equal to right hand side. So p of 1 is true. The second case is put n equal to k. Okay. So p of k is a power k, which is equal to 1 plus 2k minus 4k and k and 1 minus 2k. We can assume the equation 1 and assume this is true for n equal to k. This is assumed result. Okay. The third case is put n equal to k plus 1. So the third case, put n equal to k plus 1. Okay. So the p of k plus 1 is a power k plus 1, which is equal to 1 plus 2 into k plus 1 minus 4 into k plus 1, here k plus 1, 1 minus 2 into k plus 1. This is we prove that result, that is to prove this result. Now consider the left hand side. So what is the left hand side? A power k plus 1. How can write a power k into a? So we know that by using the result 1, a power k value is 1 plus 2k minus 4k, and here k, and here 1 minus 2k. This is a power k value, and a value is 3 minus 4 1 minus 1. This is an a value. Now multiply this 2 matrix, we get 3 into this matrix. So we get 3 plus 6k, and minus 4k into 1 we get minus 4k. And first row second column minus 4 minus 8k minus 4k. Okay. Next second row first column we get 3k plus 1 minus 2k, and second row second column we get minus 4k minus 1 plus 2k. we complete the matrix multiplication and we calculate this. Three plus 2k, here minus 4 minus 4 minus 12k. Okay, we can check once again the first row, second column. So minus 4 minus 8k, minus and minus plus 4k. Okay, so minus 8 plus 4 we get minus 4k, minus 4k, and here we get 1 plus k, and here minus 1 minus 2k. Okay, so this is an a power k plus 1, and that is a power k into a we get. Okay, next, okay, we can rewrite the value 3. How can write? 1 plus 2 plus 2k. Here the minus 4 is common value, we have take it out, so remaining k plus 1, and here 1 plus k. The minus 1 I rewrite minus 2 plus 1 and minus 2k. Okay, for our prove that result, that purpose only. So here 2 is common, we take it out. 1 plus 2 we have take it out common. So what is the remaining? K plus 1. Here minus 4 into k plus 1. Here also we write k plus 1. Here the minus 2 is take it out common, while the remaining value is 1. Minus 2 is common value, so k plus 1. So this is our proof. We can see this. P of k plus 1 equal to 1 plus 2 into k plus 1. We get the same matrix. So by principle of mathematical induction, we prove that the case P of k plus 1 is true. So next for sum, if A and B are symmetric matrices. So what does it mean by symmetric matrices? That is A transpose equal to A, we get symmetric, and B also symmetric matrices, we write B transpose equal to B. Okay, then prove that AB minus BA is a skew symmetric matrix. What is the condition for skew symmetric matrices? Skew symmetric matrix. So A transpose equal to minus A. This is a condition for skew symmetric matrix. Here we prove that AB minus BA is a skew symmetric matrix. Now take transpose on this, AB minus BA transpose, which is equal to AB transpose minus BA transpose, and applying reversal law for transpose, we get B transpose into A transpose minus A transpose B transpose. We write, given A and B are symmetric matrices, so B transpose is written by B and A transpose is A. Here A into B. Here we take it out, the minus sign is, then we get AB minus BA. Okay, so here you can see this AB minus BA whole transpose equal to minus of the matrix. So already I said that A transpose equal minus A means that is skew symmetric matrix, which implies AB minus BA is a skew symmetric matrix, hence proved. Here we see this, question number 5. Show that the matrix B transpose AB is symmetric or skew symmetric. According us, A is symmetric or skew symmetric. Here, A is symmetric matrix means B transpose AB is symmetric. At the same time, A is skew symmetric means this matrix also skew symmetric. This is then prove the result. So first we consider A is symmetric. A is symmetric matrix. Okay. So what does it mean by symmetric matrix? Previous problem I told that. So the symmetric means A transpose equal to A. Okay. So consider this, and we take transpose on this matrix B transpose AB whole transpose, which is equal to, we are applying the associative property. Matrix multiplication is always true. So B transpose into, we consider the bracket AB the whole transpose. Now we taking transpose, applying reversal law, so we get AB transpose into B transpose. Okay, B transpose the whole transpose. So here again we are applying the transpose property. We get B transpose into A transpose. This is the result for B transpose whole power transpose. The value is equal to B. Okay. So we get B transpose into A transpose into B. Here we are applying the result. A is a symmetric matrix. So A transpose equal to A. So we replace A into B. So AB. So we get B transpose into AB. Here left hand side is B transpose into AB whole transpose, which is equal to B transpose into AB. Therefore, this A is symmetric matrix. So then B transpose AB is a symmetric matrix. Now consider A is a skew symmetric matrix. So this means by A transpose equal to minus A. This is the result. Now applying B transpose into AB whole transpose. So which is equal to, so we already proved that in the first case. So we directly take in the result. So I write the result B transpose into A transpose into B. Here A is a skew symmetric matrix. So A transpose is replaced by minus A. So B transpose into minus A into B. So we get minus B transpose into AB. Here we can see this. What is the left hand side? B transpose AB whole transpose, which is equal to minus the same matrix B transpose into AB. Therefore, A is a skew symmetric matrix, then B transpose AB is a skew symmetric matrix. Hence, the matrix B transpose AB is a symmetric or skew symmetric according as A is a symmetric or skew symmetric. I hope you are well understand. Keep watching my all videos. Thank you to all.